Now we also need to talk about determining data security controls. So baselines, scoping and tailoring, standard selection, and a little bit about cryptography. And we're going to talk more about cryptography in a later domain, but we're going to touch on it here, talking about security controls. So a baseline. We have to have baselines. We need, quite simply, something to compare the current events with something, or against something, I should say. So if we know the norm and something's happening, we can say, oh, this is happening, let's look at the baseline. Effective network security demands an integrated defense in depth approach. Remember, I talked about defense in depth in domain 1. Right? We have the data, the good stuff that the hackers are trying to get to, and we want to put layers here. A defense in depth. Put a policy out here. Have a good policy. It's more of a deterrent, right? Administrative control. Don't do this, or this, and this may happen to you. But that policy is not going to necessarily stop me from hacking that system. It's not going to come out and stop me from typing. It's not going to cut the data communication link off. It's more of a deterrent, right? And the closer we get to the data, the closer we're getting to the end system, the endpoint, the laptop or the desktop. So we could have network security. We could have agents and network devices, IDSs, IPSs inside a firewall. We could have host-based intrusion systems, antivirus. And we're moving closer and closer to the data to protect that. Now, the first layer of defense in depth approach is the enforcement of the fundamental elements of network security. Now, these fundamental security elements form a security baseline of what we're supposed to do. These create a strong foundation on which more advanced methods and techniques can be built upon, like I was talking about, right? Fundamental out here, and we get more and more technical or advanced as we move in. So the objective of baseline protection is to establish a minimum set of safeguards or controls to protect all or some of the IT systems in our organization or inside of our enterprise. So key words there, baselines and minimum set of safeguards or minimum set of controls. We need something to compare that against. We're going to baseline that system. This is the standard, this is the minimum that it can have. It has to have antivirus. It has to have a host-based firewall. It has to have the latest application patches. It has to have this and has to have that. It has to have a logon banner. It has to, we can go on and on and on. But that's the baseline. That means any system that doesn't meet that baseline, those minimum requirements, may not be allowed on the network, may not be allowed inside of the infrastructure. We should have policies in place that establishes this baseline. That could be an IT policy, because usually the IT team are the ones that say create images or build our computers. And when I say build, I mean install the operating system, install our applications, install our patches, update everything for us. Get it to that baseline so now it can go out in production and the end user can start using that device. So an enterprise may generate its own baseline. We did that at one of my old jobs. We said it had to meet this minimum security for all end users. Now, our servers had a higher baseline. They had more strict requirements, like password complexity requirements, who could access that device, and so on and so forth. Now, an example of an approach found by examining the United States government configuration baseline. So they established their own baseline, the USGCB. Now, the purpose of this initiative was to create a security configuration baseline for IT products widely deployed across federal agencies. So whatever federal agency has, they had to meet this government configuration baseline of security, the minimum protection that they have to have. If not, then they're not allowed on the federal agency's infrastructure or network. They should not be allowed to access that data. because they don't meet that baseline. If we don't meet the baseline, we could be introducing what? I won't give it away. Vulnerabilities. That's right, because that's a weakness. And again, we're only as strong as our weakest link. If we have a system down here that's not meeting the baseline, this is our weakest link. So it doesn't matter how strong we are across the board. Once we introduce that one weakness, hackers, attackers, those threats can take advantage of that and exploit that vulnerability. Now, scoping guidance provides an enterprise with specific terms and conditions on the applicability and implementation of individual security controls. So system security plans should clearly identify which controls employed scoping guidance and include a description of the type of considerations that were made or that are going to be made. So we have to be able to clearly identify which security controls are going to be employed. That is our scoping. Now, tailoring, that involves scoping the assessment procedures. So we're going to get in and see the procedures of our assessment here to more closely match the characteristics of the information system and its environment of operation. We're going to see how it's operating out there inside of our infrastructure. Now, this process gives flexibility needed to avoid assessment approaches that are usually unnecessarily complex or costly, which at the same time meets the assessment requirements established by applying the fundamental concepts of our risk management framework that we talked about in domain number 1. And then the standard selection. We can all meet a standard, and there's dozens of standards out there. So you, as a security professional, security practitioner, we need to be familiar with the range of standards and the organizations, the entities that are responsible for them. Now, probably, I guess I can safely say this, one of the most popular ones out there for when it comes to standard is NIST, right? That's based in the United States. Now, we also have some transnational entities that you kind of need to be familiar with. The European Network and Information Security Agency, the International Telecommunications Union, which we've probably heard of before, and the International Standards Organization, which I'm sure you've heard of before because, well, they've been around for quite a long time and they've got their hands in lots of things. So a couple of those standards we need to be familiar with, right? Now, we could have a whole course on NIST and all the standards that they have out there for us, but be familiar with NIST. And then cryptography. When it comes to cryptography, it's a huge subject, right? Huge topic. Some people love it. some people hate it. Cryptography, we're hiding information in plain sight, right? I can have some plain text data, and I want to protect that data. I don't want you to be able to see it. I don't want you to be able to use some type of wire sniffer or protocol analyzer and you see that traffic going across. I don't want you to be able to get into my hard drive and see the data that I have. That's my data. So I can protect it with cryptography. I could encrypt it. It's still there. You can see it, but you don't understand it. That's the plain sight of it, right? It's hidden. It's jumbled up in plain sight, but you can't understand it. Now, if you was to get on my hard drive, or get on my laptop, I should say, and you look at that data, that data is not going anywhere, and that's considered data at rest. So if I have data at rest, it's not going across any communication line or medium, I need to do something with that data to protect it, right? Remember the CIA triad? I want to protect that confidentiality. I want to protect the privacy. So encryption of the data at rest is totally necessary. And I highly recommend you doing that on your personal systems, and I'm sure your enterprise has a policy about data encryption as well. Now we can do hard drive or per file encryption. So we can encrypt the whole hard drive if we wanted to. So every time you tried to log in, not only would you have to put in your credentials for the operating system, you'd have to put in credentials to unlock the drive for that encryption. Now that encryption, for that data at rest, we could have hardware-based encryption, or we could have software-based encryption. And software-based is actually not too bad. There's free ones out there that you can go get, and you could start encrypting information on your hard drive today, right? I highly recommend you go do that, because you never know. You never know when accidents can happen. You know, when can your laptop walk off? When can your mobile device walk off? And if it does, what data on there did you have that you don't want people to see? Is there confidential information on there? Is there secret information on there? Is there private information on there? If somebody steals that device or borrows that device, and you don't have that encrypted, that data at rest encrypted or protected somehow, the confidentiality is gone. Could affect integrity as well, because if you ever get it back, let's say you get the device back and you didn't have encryption or a way to protect that data, now you may be infected with something, or some of those files, some of that data that you have may have been compromised. So now the integrity of the machine is no longer there because it was out of your control. Now we also have data in transit, right? So that's data at rest. But what if we're moving that data from point A to point B, back and forth? Because we're moving data all the time. You get on the internet, you're moving data, right? You surf the web, you go to your social networking site, social media site, you're surfing the web, you're moving data. You submit a form, you're moving data. You do online shopping, you're moving data. You copy a file from your laptop to another desktop or to the file server, you're moving data. When you copy information from your laptop to a removable hard drive, you're moving data. That's all data in transit. So let's talk about from point A to point B, say across the internet. How can we secure that? Well, we can use link encryption or I should say, end-to-end encryption. Link encryption, we're going to encrypt the whole communication, the headers, everything, our protocols. End-to-end encryption is from one endpoint to another endpoint. So let's say we have to go across multiple routers, or we have two routers in between me and you. End-to-end encryption will go from my endpoint to the next router. Now that data may not be encrypted while it's in that router, but once it leaves that other router and moves on to the next router, the end connections are going to be encrypted. So it could be encrypted, unencrypted, encrypted, unencrypted, encrypted until it gets to the end. Link encryption will do the whole pipe. Now, a couple things we can use, and again, we're going to talk about these more a little bit later, but things like SSL, TLS, IPsec, AES, all right? Lots of industry standards that we can use out there for this data communication encryption. So encrypting the traffic as it moves is just as important as data at rest encryption or that protection. People usually don't think about one or the other, right? You may encrypt your hard drive. Outstanding, that's great. But what if you send me a file? Is that data encrypted? Can anybody intercept that data between you and me, right? And if it is encrypted, how are we going to encrypt it? You know, if we do symmetric encryption, which we haven't really talked about cryptography too much yet, but if I did symmetric encryption, how are you going to get me that pre-shared key? How do I know how to unlock it now, right? All things we have to think about. But what I want to focus on here right now is data at rest and data in transit. If it's at rest, it's on that system. If it's in transit, it's moving across some type of medium to get from, say, point A to point B or C, D, E, depending on what type of mechanisms you use. And then we want to establish handling requirements. All right, so just like with our physical assets, it's important that classified information, that classified assets that we may have are clearly marked and they're clearly labeled. We want to make sure they're labeled properly. Again, so people understand how important or unimportant that particular asset is. If it's something that we have to hold on to, this is going to affect our data retention. If it's very important, if it's medium importance, low importance, is it something that we can delete? Is it something that we have to securely delete? Remember, we talked about the data remnants. If I just deleted it and not worried about wiping it or sanitizing that disk, is it going to be okay? Talking about handling requirements, what about encryption? The data at rest and data at transit we just talked about, right? How are we handling that information? How are we, as the custodians of this data, or it could be the data owners, how are we handling the data that we've been entrusted with now? So that record retention and disposal. A couple different ways we can do this, all right? We can use strip cut shredders, which they've been around for a long, long time. Those are those ones that you see that cut the paper into long, thin strips. So what we're talking about here is hard copies right now, right? So you get those long strips. Now, yeah, it looks cool, and your data may be destroyed. But, is it possible for somebody to reach in to the wastebasket, pull those strips out, and start putting the picture back together? Start putting the puzzle back together. Yeah, it may take a lot of tape, it may take a lot of time, but it is possible. So they take it a step further. They come up with cross-cut shredders. Now, they cut them in these strips, but then they cross-cut those strips. So now instead of having long strips, we got a bunch of squares. So now it's making it even harder, right? Because now it looks like almost like snow inside of the wastebasket. Now you can reach in there and grab a handful and plop it on the table and start spreading it all out. And if you're really good at puzzles, then have at it. But it's going to take you a while. You could have particle cut shredders. These are similar to crosscut. Remember, crosscut, we got the long strips, and every so often, maybe every 2-3 inches, it does a crosscut. So the paper will come down the shredder, and a crosscut will come across. And it goes down a little bit more, it comes across. A little bit more, it comes across. So now we got these shorter strips, if you will. This particle cut creates tiny squares or circular fragments now. So now it's even smaller. So we're getting smaller and smaller and smaller of what we're doing to these records, these pieces of paper. Now we also have something called a hammer mill. I don't have any first-hand knowledge with that, but that pounds paper through a screen. So we have a screen here, and it's hammering, hammer mill. It's pounding that information through that screen. And if you think about a screen, those holes are extremely tiny. It will almost, I don't want to say liquefy this paper, but it's going to make it into powder pretty much. I would say nearly to impossible to reverse engineer, if you will, or put it back together. There's not going to be any way possible to do that with this. Now you also may have a granulator or a disintegrator. You're repeatedly cutting that paper up into fine mesh-sized particles. Again, I'm going to venture to say that's impossible to put back together. All right, the last three, I wouldn't want that job. I'm just telling you that right now. I don't want to have to put that information back. I don't want to put the information back together for any of those, really. But the first one, the strip cut, is not too bad, especially if there's not very much paper in the wastebasket. But these other ones, we're getting smaller and smaller and smaller and smaller particles. And if you disintegrate it, there's nothing to put back together. So that does make it impossible. Now, there's different security levels that you may have to have. Again, according to your organization, if you work for military, government, your enterprise, your organization, or just your home. So we have levels 1 through 6. Now, level 1 is the least secure. What that does is cuts papers into the 12mm strips. Now, this is not usually suitable for classified information because, again, that's not hard, right? 12mm, that's not very large, right? But it's not very small either when it comes to putting puzzles back together. So if I have strips of 12mm each, again, if I'm in a waste basket that's got thousands and thousands of strips in there, yeah, that makes it a little harder. But if there's not very much in the waste basket, I could put that back together pretty quickly. We have level 2 that cuts paper into 6mm strips. So we're getting smaller now, right? We're going to have more strips and they're smaller. Again, not suitable for classified information. Level 3, now we're getting even smaller. We're going to 2mm strips. This is somewhat suitable for confidential information. Level 4, now we're cutting paper into 2x15mm particles. Now this is suitable for sensitive, but classified or business proprietary information, maybe not so much. Level 5, 0.8 times 12mm particles. This is suitable for classified information. Level 6, 0.8 times 4mm particles. So it's really, really thin, really, really short, suitable for top secret information. So you can see 6 different levels we have there, and the higher levels we go, the more secure we are getting. Now you may not have levels 4, 5, and 6 in your home. You may have something that you can go buy at the local department store in your house. Maybe you hit level 1, level 2. You may have level 4, that cross cut. That would be one of those cross cuts, right? Pretty popular nowadays. Pretty popular in enterprises as well, right? Because they have proprietary information, confidential information, private information that they can't let get out. It may be about their customers. It may be about their employees. It doesn't matter. A lot of people use these strip cutters, these shredders, to shred up their documents. Now a little bit more about the record retention and disposal. So the methods of destroying data contained on magnetic media, like our hard drives, various techniques for clearing and sanitized data are available to us. So we can use erasure or reformatting. If we do that, let's say I have a hard drive and I erase that hard drive, is the data really gone? Remember, we talked about data remnants. Is it really gone? How many times do I need to erase it or reformat it? We can do disk wiping or overwriting. Now, what this means is that we're taking that hard drive and we're writing over existing data, typically with streams of zeros and ones in some type of random pattern. That's pretty secure. So we could take that information, we could erase it, overwrite it, erase it, overwrite it, erase it, overwrite it, right? There's tools out there that will do this for us. Now, you're going to need some time, okay? This does take time depending on how large your drive is. I think the first time I did this, I might have had like a 300 or 400 megabyte drive, right? Way back in the day. And it didn't take as long. Now I have terabyte sized drives, and it takes a few hours for this to occur, especially if you're doing the disk wiping and overwriting, because some tools you can do it once. May not take very long. But what if you wanted to wipe it and overwrite it and wipe it and overwrite it? Let's say you wanted to do that 4 or 5 times to make sure you're really secure. That's going to take a while, because if the first time takes an hour and a half, multiply that times 4 or 5. So you're looking at an all-day process. So you're going to just let that bad boy run until it gets done. Another technique is called degaussing. Now this is a technique of erasing data on a disk or a tape, magnetic data, that when performed properly, this ensures that there is insufficient magnetic remnants to reconstruct the data. Because inside of that hard drive, those platters that are spinning around, that data is held on there by magnetism. And if we mess with that magnetic field, that data can't be kept or stored on that data drive anymore. Can't be on those little platters that are spinning around inside of that hard drive. Now this is performed with a machine called a degausser. Now this applies a magnetic field, like we just talked about, to the media and then removes it, eliminating the residual magnetic signals on the media. Now I've seen one of these, and you can have them handheld, right? Where you can just put it right on top of the disk and it does its thing. You hold it there for a couple seconds and it's done. I've also seen them where it's a big, almost looks like a furnace maybe, if you want to look at it that way, but you open the door and you can put in dozens, if not hundreds, of hard drives at a time. So that way you don't have to take your hand out, go to the next one, and then go to the next one, and then go to the next one. You can put them all in there at once, close up the door, right? Hit the button, let it do its thing for a second or two, and then you're done. Now all those drives should be sanitized or wiped completely. They're demagnetized. Now, by the way, when you do this, they're no good anymore, right? The magnetic field, the remnant, pulls all that off. So if you want to use that hard drive again, this might not be your best option. Now, this is the end of domain number 2. So we talked about the classifying of information and supporting assets. We talked about determining and maintaining that ownership. We talked a little bit about protecting that privacy, assuring appropriate retention, determining data security controls, and finally talked about establishing those handling requirements.